Hello, I'm Kevin Pouget. I'm a senior software engineer in Red Hat Performance and Scale department in the team in charge of accommodating performance and latency sensitive application in OpenShift. In this video, I'm going to talk about NVIDIA A100 GPU, which is a high performance GPU able to partition itself into multiple GPU instances. These GPU instances, it's called MIG for multi-instance GPU. And I'm going to demonstrate how it works in OpenShift with the latest release of the GPU operator. So in this screen, we can see on this side the different information about our node which hosts the A100 GPU. So it's currently partitioned in 7 instances of GPU with the smallest capability. So this part, it's what is exposed to Kubernetes as extended resources. So you can create a pod and request any number of these MIG instances. The advertisement strategy is currently configured as mixed. This way we can have different sizes, different geometry of MIG instances in this different set. So what I would like to demonstrate is the ability of OpenShift to reconfigure the MIG partitioning. And for that, we've got multiple daemons running on the cluster, and one of them is the MIG manager. This MIG manager, it's a Kubernetes controller that is deployed on all the nodes with MIG devices, and it will watch for node labels, in particular this one, which says which configuration we want to apply to the GPUs on the node. So if we follow the logs of this controller in this side, and then we apply a new configuration, let's use all bar length. We apply it, we notice that the MIG controller detects the modification, so it will query the state of the node and reconfigure the MIG device to match the request. And in order to perform the reconfiguration, the MIG manager needs to disable all the daemons that are currently running on the node. So the daemons are the device plugin, the DCGM exporter, which exposes metrics about the GPU state, and the GPU feature discovery, which exposes the labels of the GPU. So that's the first task it's performing, shutting down the different daemon sets by removing the labels in the node. So it's waiting for the last daemon set to shut down. We see already that the device plugin has been shut down, so no more MIG GPU are exposed. And the new configuration has been applied. 2 smaller instances, 1 medium and 1 a bit bigger. And now the controller reapplies the different labels of the node so that the device plugin, the GPU feature discovery, and the DCGM exporter gets redeployed by the daemon set controller. And we see that the device plugin has been relaunched. It now exposes 4 different MIG instances, and the GPU feature discovery also exposes with node labels the different capabilities of the node and the GPUs inside the node. So let's wait for everything to be successfully redeployed. So all the daemon sets are here, so we can launch a benchmark. So in this benchmark, I will take one configuration, the 3 GPU instances, 20 gigs of RAM, and I will request 2 of them. So this is the part we see in this resource stanza of the pod definition. What my script does is change the label of the node, and then it will simply wait for the pod to start running. So currently the pod is shown as pending because there is only one MIG instance available with the right size. And as soon as the reconfiguration will have been performed and the device plugin relaunched, then we'll see multiple numbers, maybe 2 or 4, and the pod will be successfully scheduled in the node. So let's wait a few seconds for the reconfiguration. And here the reconfiguration has been done. There are 2 GPUs of this kind available. And in this config map, we see all the possible combination of slicing that has been pre-populated by NVIDIA. So first part is for the A100 40 gigs, A100 80 gigs, and below we see more complex systems with multiple GPUs, but the config file has the ability to configure each of the GPUs as needed. And now all the GPUs, the MIG instances are ready, and the pod turned running, and it started executing my benchmark. Thanks for watching.